Welcome back. Let's talk about our first big word when it comes to functional programming. It's called idempotence. I know it's a hard one to say, but what does it mean? Well, let me show you with an example. If I have a function, and we'll call it not good, and this not good function is going to return math.random. If I call this function and I click run, well, I get a random number between 0 and 1. And what idempotence means is that given the same inputs, in this case, we have no inputs, or you know what, let's just add a number in here, and click run. All right, every time we get something different. If I do 5, no matter what, I still get something different. The idea of idempotence is a function that always returns or does what we expect it to do. Now, that sounds familiar with what we've just talked about pure functions. But it's a little bit different because if I do console.log 5 here, or just num here, and I click run, no matter how many times I click run, I always get 5. This function that console logs 5 to the outside world is still idempotent because multiple calls is still going to display the same text, even though it's not pure because, well, it communicates with the outside world. Another thing that can be idempotent, for example, is deleting a user from a database. When we delete a user from a database, well, I can delete that person once, but if I keep calling the function to delete that user, well, it's going to return the same result. It's going to return me that empty field where there's no more user. And things like idempotence, you see a lot in APIs like HTTP GET requests. I can do an API call, and I expect that that API call, given some sort of parameter, is always going to return the same results, even though we are communicating with the outside world. Now, why did I teach you this? Why can't we just say everything should be pure? Why do we care about idempotence? Well, because this idea of being able to call something 1,000 times and always giving you the same results is extremely valuable when it comes to things like parallel and distributed computation, because it makes our code predictable. By the way, another interesting feature of idempotence is this idea of being able to call yourself over and over and over, or inside of yourself, and you still get the same result. For example, the math.abs or absolute, which if I do minus 50, well, abs, not APS, I'll get a positive number or an absolute number every time. If in here I call math.absolute again, I get 50 again. So no matter what, calling this function over and over inside of itself always returns the same thing. This is pretty amazing. And with that in mind, we have these guarantees of code being predictable. All right, idempotence. We got that right, so let's move on to the next word.